All right, guys, I wanted to wrap up part one for chapter 7 with some practical applications of Boyle's and Dalton's law and how they apply to pulmonary ventilation. And with that, I wanted to dispel a myth that people commonly assume with working out in altitude. So people tend to say that in altitude it's hard to breathe because there is less air. We're going to showcase that the amount of air present in altitude is the same anywhere on Earth, but it's all about the pressure. So I wanted to showcase here what happens as we kind of climb up in different altitudes, starting with sea level in a place on Earth that you guys already know about. The amount of pressure that we feel at sea level is about 760 millimeters of mercury. Again, that is the partial pressure of nitrogen, oxygen, argon, and some other trace elements such as CO2 and water. However, as you start going up, we see that the atmospheric pressure drops. So if you're gonna go to Mexico City, you're gonna be at about 2,200 meters, about 2 kilometers above sea level, and the amount of pressure that you're gonna experience while you're in Mexico City is 590 millimeters of mercury. If you were to the highest capital in the world, which is in La Paz, we're gonna go to 4,000 meters, so 4 kilometers away from the sea. We see that the pressure drops even further to 463 millimeters of mercury. And of course, if we're going to take to the extreme, to the highest point on Earth, to the summit of Mount Everest, we're gonna go and more than double the distance from the sea to about 8,000, almost 9 kilometers away from the ground. And we're gonna see that that atmospheric pressure is gonna be about 250 millimeters of mercury. So the interesting thing is, let's say that I get a bottle and I fill with air at St. Kate's, and then I fill the bottle of air in Mexico City, and I fill the same bottle of air in La Paz, and I fill the same bottle of air in Mount Everest. First, I am gonna have a lot of air miles on my card, but if I were to analyze the gases inside it, guess what I'm gonna see? For every single one of those bottles, I am going to measure nitrogen at 78%, oxygen as roughly 21%, and then we have your trace elements that are going to make up the difference, 2%. So this whole idea that in altitude there is less air is not correct, because the amount of air, the composition of the air from St. Kate's to Mount Everest is exactly the same. What does change is the pressure that these gases are going to exert on your body. And to illustrate that, we see that at sea level, with 760 millimeters of mercury exerted on you, if we were to account for the partial pressure of air, then nitrogen exerts 78% of that pressure, and oxygen is about 21% of that pressure. We know that the amount of pressure that oxygen actually exerts on your body is 160. As it moves through your body through pulmonary ventilation, some of the pressure is lost internally, and the partial pressure of oxygen in the alveoli is actually as low as 105. So let's take the example of La Paz, where we go to 4 kilometers away from the sea and the pressure drops to 460 millimeters of mercury. Again, the composition of the air is still the same, but you guys are going to see that the partial pressures are completely different. And now we're seeing that the partial pressure of nitrogen drops to 361 and the partial pressure of oxygen drops to 97, even below what the partial pressure of oxygen in the alveoli is at rest when we are at sea level. Now, the closer we get to this 40, the harder it's going to be to create a gradient. So the greater the gradient between the partial pressure of oxygen in the alveoli and the partial pressure of oxygen in the capillaries, the easier the movement. The closer these two numbers are, the slowest the movement. So things move from a concentration of high to low. If the high and low are pretty close to one another, they don't move as fast. This plants the seed for us for part 2, which we're going to talk about the determinants of diffusion. And you guys are going to see that the partial pressure of air is going to be a big determinant in how much oxygen crosses the barrier from the lungs into your blood to be transported to your tissues. But we're dispelling the myth here that in altitude there is less oxygen. There is the same amount of oxygen as there is at sea level. What changes is the pressure that the oxygen exerts on your body.